Hi, welcome to GMST Solutions Private Limited Digital Learning. In the part of how to crack full stack Java interviews, the question number 24. So, what is list in collection? So, first of all, what is the collection? The collection already we have discussed clearly in previous example, the previous video. Please go through that video and watch at least few times for understanding in better way. And so there I have explained clearly what is the advantage of using the collection and what are the drawbacks we are facing for the primitive types and array type. Now, the collection part, what is the list interface? List is the interface actually. So, how we can implement with the list interface implemented classes and what are the implemented classes we have? And list is sub interface for the collection. So, these things we'll discuss in hierarchy wise. So, the first of all, collection is the root interface. Collection is the root interface, and so we have the sub interface for the collection is a list. So what are the methods and properties we have from the collection? We will get into the list interface. The size method, add method coming from collection interface only. So list is also interface. For interfaces unable to create object. So collection maintains the data randomly. Based upon your implementation, it will stores data either for the list type, and set type, q type. But collection it will provide the random display output. And if you go for the implementation classes, based on that what is the structure it is maintaining in the implementation class, like that we will get the output. Now, so the collection is the root interface. For collection also, what is the root interface? Iterable. If interview point of view they're asking what is it root interface for the collection, also behind that iterable. The entire our collection data is the iteratable data. We can iterate over the any collection elements. It's iterable. Iterable and collection list. So the three are the interface only. Now, so unable to create the object for the interfaces in Java. But if you want to see the output and if you want to do the manipulation and implementing that interface services, we have the implemented classes. For list, we have, if you go for the list, we have array list is the implemented class. And another one we have the linked list. Linked list. And if you go for the 1.0 version of Java, there we have vector and stack. Vector and stack. These two coming from the JDK library 1.0 version, and these are all coming from the 1.2 version. See, here I'm giving the each and every library, so the interface and class clearly. Please, if you want to make the notes, you can make it. So iterable is the iteratable over the your any collection data. There we have the methods to iterating over the our collection data. And the collection is the root interface for the entire collection framework, one dimensional. One way of data we can add and read the data. So for that, what are the one dimensional means? List to set to queue. So these are the interfaces. And coming to the list, a list allows the duplicate values. A list allows duplicate values and maintains insertion order. A list allows duplicate values and maintains insertion order. The output displays in insertion order. Output gives in insertion order. Insertion order in the sense, if you give the input is the first is 100, you will get the 100 only. So like second is 2, you will get the second is the 2. the numerically. So based on means how you are inserting the values, the same way you will get the output also. Okay. And if you go for the list interface with the implemented classes, the array list is the index based storage. Array list is index based storage. I'm giving here. Array list is index based storage. And if you go for the linked list is node based storage. Linked list is node based storage. Node based storage. Vector is same like index based only, and stack is last in first out hierarchy LIPO. The storage maintains internal is a LIPO, last in first out hierarchy stack. But coming to the other list is I'm saying the index based storage. So what is the index based first of all? Okay. So here you can see. So the index starts from the 0. So 0th index, first index, second index, like that, and so on. You can take the n number of index. It is a dynamically growing in nature, not like array static in nature. Array is static in nature, but array list is dynamic in nature. It will grow in dynamically, and the data stores internally. Index based, but output is insertion order. How we are inserting, the same way we'll get the output. So example, I'm taking the few elements to the your list or array list, any elements to the collection object or list object. Now see, example, I'm taking 100, 30, 200, 7. So like this, I'm taking the elements. The 0th index, the stores the element is the 100, and second index is, that is the first index is the 30. The second index is 200, and third is the 7. So how we are giving the input, the same output also we will get in the in list up entire list objects. List provides insertion order output, and the internal storage mechanism is based upon your implementation class. If you go for the array list, index based. If you go for the linked list, node based. Node is nothing but every node have the data and address part. Here the node contains data part and address part. I'm giving the few nodes just for understanding purpose. So this is a simple one node. Okay, the same values only if you want to store in the linked list, we can store it. Now see, 100 is the first giving input that stores in the node 1. Stores in node 1. Node 1. So each node contains a data part and address part. Address we will provide internally automatically. The JVM will provide. Okay. But if you go for the custom nodes, we will take care about the what is the first node and next node and middle node. Then we will connect to the each and every node into the in linked list format, linking between the one node to another node. Okay. So here I'm taking the data part is 100 now in node. Data part is 100. Maybe you can imagine internally is the address of first node is maybe 1000. Okay, JV to provide the automatic, no need to provide ours. Okay, ourselves. See, the node one contains the 100 is the data part and the 1000 I'm giving the randomly for imagination purpose. 1000 is the data, that is address part. So address node 1 address is a 1000, node 1 value is a 100. The storage mechanism. If you want to come go for the next node, node 2, okay, node 2, the 1000 plus 1 is the forward direction. 1000 plus 1 is the forward direction. It will take the linking between the one node to another node, contains previous node reference and first node. So what is the middle node? That is node 2 is the middle node I'm thinking. Okay, another node will take it. So what is the previous node? 1000. And what is the next node? 1000 plus 1 for the node 1 now. If you go for the node 2, previous node is the 1000 and current node is the 1000 plus 1. Okay, next node is 1000 plus 1 plus 1. So like that we can take the internally the JVM reference. So every node contains data part and address part. Every node contains data part and address part. So example, second node value is the 30. So now the reference I'm imagination, our imagination we are taking here is the 1000 is the first node value. Okay, and the second node value I'm taking here maybe 1001. Okay, the from node 2, if you want to go for the previous node 1000 minus 1, if you want to go for the next node, okay, 1001 plus plus 1 if you want to go for the next node. Okay, the same way you can take the another node. Now node 2 is the middle node. The for node 1 previous node there is no previous node, and last node there is the address part is the null because I'm taking only 3. So last node is the 3. So when you are closing the nodes at last, the last node address part is the null. First node there is no previous node, and last node there is no next node because that is address part is the null. So previous node we have 1001. Okay, the 1001 we have, and from middle node to next previous node is a 1001 minus 1, and next node is the just we have the node 3. The node 3 will be take 1001 plus 1, but the address part is the null actually whenever you take the last node in our list, linked list, null here, but reference for the middle node, reference for the middle node is 1001 plus 1 I'm taking here, internal reference. So not exactly, but we can go for the middle node to next node, and the previous node 1001 minus 1, that is 1000 previous node address. So like this we can go for the node format storage in linked list. So node 1 contains the address, this is the data part, this is the address part. Address part we will take care, JVM will take care. So every node, starting node there is no previous node. In every data the linked list last node is the null reference. So for this if you want to take the element, what is the third element is 200. So like this we can store the elements, n number of elements we can add it, not only 3 we can take n number of, but understanding the, so any node. So node 2 is the middle node, for previous node is the node 1, next node is the node 3. The address part like, so 1001 is the middle node, so minus 1 is the previous node, plus 1 is the next node, but the last node address part is the null in the linked list. So all the nodes. What is the advantage in the linked list and array list? So array list is maintaining in the index based storage and insertion order output. Linked list is the node based storage and output is insertion order. So entire list objects insertion order only we will get, even stack, vector, everything. The output is insertion order only. But Based upon the class implementation, every implementation class have the different storage mechanism. Array list is index based and the linked list is node based. Vector is same like index based, but it is old collection framework 1.0 version. And stack is old collection. The data storage is last in first out. Last in first out in the sense we given the element is that 100 is the first. So I'm taking the reference for you. Adding the element to their stack. Okay, stack we are adding 100 first, second 30, third is the 200, and last one is the 7. It will store internally in stack object, the stack mechanism, last in first out hierarchy. So what is that? Last in first out hierarchy. So like this it will stores. So last in means the last element in the top position, the first element in the last position. So we added the first element is 100, it will be in the last. And then and then 200 and finally 7. It will store like this. Insertion is this is the order 100, 30, 200, 7. But storage mechanism is the last one is 100. Okay, 100 last in first dot. The first insertion is the last, and 30 is the from last to second, and 200 and 7. So the last input what inserted, that is a 7. It will be stored in the top position, last in first out, the storage mechanism. We are inserting like that, but storing in the your stack object is last in first out. That is a LIPO hierarchy. So we have a few methods like a peek, pop. Okay, peek means it will print in the top element. Push it will add the top position. Pop it will delete the top element. So these are the inbuilt methods from the stack. And coming to the overview again once again. So what is the list in collection? So see, list is the interface. It is a sub interface for the collection. Collection is the root hierarchy, the root interface. For collection also we have the interface. Root interface is iterable. So because entire collection framework is iterable data, we can iterate over the our collections. And coming to the list interface, list allows the duplicate values and the output gives an insertion order. Insertion order in the sense how we are giving the input to the your object, the output also same order only will get. But storage mechanism depending upon your implemented classes. So means so iterable interface, collection is interface, list is interface. For interfaces, unable to create the object. So example for interfaces in Java, we cannot create the object directly. So we have to go for the implemented classes only. So then the implemented class hierarchy, how it is there. Okay, the implemented hierarchy, how it is there. Example, if I go for the array list hierarchy is the insertion order, that is index based storage. Index based storage. So index based it will stores in the elements. So how we are inserting to the your array list object. If you go for the linked list is the node based storage. So whenever we adding the element to the your linked list, it will stores on the each and every node data part and address part. Address part will take care about the JVM. When you go for the vector, vector is the old collection framework. So it will follow the index based only like array list. And stack is last in first out hierarchy. So LIPO. How we are inserting? The first inserted element will be last inserted element in the top. Okay. And so these are the classes. I is the interface. Okay. C is the class. Implemented classes. So for classes, we can create the object. Certain issues, we can create the object. But by default 1.0 version collections are the synchronized collection. There is a thread safety. So vector and stack is a 1.0 version. Remaining entire the collection is a 1.2 version. Okay, so 1.2 Java version. So 1.2 version collections are non-synchronized, means there is no thread safety. 1.0 version collections are the thread safety collections. There we have the thread safety, locking and unlocking on the object. So this is a theory about the at least list interface information, the array list, linked list, and vector and stack. How we can add the data to the array list, how we can add the data to the linked list, how we can add the vector and stack. Okay, so we'll take the simple example and see the output. What I'm giving the points. Entire list interface allows duplicate values in session order. Based upon your implementation classes, it will store sentinel in the index based. So for index based, if you have the already element in the first index, there is a 30. If you want to add the new data, what will happen? The 30 index value will be going to next second index value is going to third index, like this. If you have the n number of records, 1 crore records or more than that, what will happen? The shifting will happen in the array list index storage when we follow the any update operation. If you are using the array list for the update operation, so means if you want to add the existing data, so 0th index percentage already element is added. If you want to add the one more element in between, what will happen? The indexes will be shifting in internally. So we won't get it for seeing the physically, but it will happen internally. See, the index shifting will happen is nothing but, so more than 1 crore millions of records, it will take time consuming process for the updating operation. So if you go for the array list using the update operation, it is poor performance and not recommended, and application will take time to existing data shifting to the another indexes. So there is a disturbing in between your existing data. So don't go for the array list for update operation. Means example, you have the edit button in the any social media. If you want to add the new data, so if you use the array list, it will take time consuming plus slow performance. But array list is very fast because of we will extract the data with the help of O of indexes. O of indexes. So very fast we can iterate over the data and we can set the elements. Example, if you go for the suggestions, when you are typing in the Google, there is a Java, you will get automatically few things like you can take any reference. Example, here I'm typing the something searching purpose. For searching purpose, when you are entering in the Google Chrome or any search engine, there is a suggestions like you can go Java download, Java tutorials, like that you will get the suggestion. There we can use the for searching purpose. Array list is very fast. Coming to the linked list. Linked list is a node based storage. If you want to add the new data in between the nodes, we can add without disturbing. So for updating, linked list is the best suit and preferable for the updating operations in your application where we have the frequent update operations. Very fast. And if you go for the searching operation for the linked list, it will loads the data in the node format. Each node have the address and the data part. The data part contains address. The time consuming process compared to the array list is a slow. Means for searching purpose, not recommended linked list. For update purpose, linked list is best. We can go for the updating operations with the help of linked list. If you go for the array list for updating is very poor performance. So we have to go for the array list is for searching operation. It is very fast for the search operations. So I hope clear. Array list is for the fast iterating over the data. We can achieve very fast search operation with the help of the array list, where we have the frequent search operation. And the linked list for updating purpose, we'll go for the linked list. Very fast update operation we can achieve it. And the vector is same like index based only, but it is old collection framework synchronized. Stack is last in first out hierarchy. Example, when we go for the any library, or if you go for the latest items, example, if you Amazon or Flipkart, there is the latest added elements. So the latest added means the last added element in the top position. Or if you want to go for the any order menu in Swiggy or Zomato or somewhere else, what is the latest updated element or latest new added element to the any menu list for the particular hotel? So if you want to get the data, the recent added elements in the top position will go for the stack. Last in first out is nothing but fresh elements in the top position. That is the last added, recently added in the top position. The old data in the bottom position, the last. Okay. What is the element added in the just recently? That is the last inserted element in the top position. When we added in the previously, that is in the bottom position. So inserting data is the first this one, but it is the old one. It is the latest one. Latest one in the top position. Old one is the last position. So the stack hierarchy storage mechanism internally. So just to see the example and we'll close for this. So I hope theoretically everyone understood. So about list, okay, just go for here. So just take the main method. So the entire list is maintains insertion order and allows the duplicate values. See, so we can create the object for the list or collection for the array list implemented classes. See, we can go for the collection is the util package, import the util package. So you can take any type of element in collection, but if you want to take the generic type, okay, we'll take another example on the generics. What is the generic? Okay, so generic type means, so it will allow the only typecasting data, means what are the type data we are entering. If you go for the integer type data only. If you go for the string type data only we can expect another different type and the different type of objects. So I'm taking the raw type collection. So data new implemented class. We cannot create the object for the any interfaces in Java. You will get the compile time error. You will get the cannot instance date. So the type collection. See, for interface directly we cannot implement the object. So what we have to do? Implemented classes. A list is index based storage for searching very fast. Implement is the index. The storage mechanism is the index based, but output is same like insertion order only. This is a list object. So this is the one way. Another way we can create the same object, list object, that is a list interface, data, new array list. This is one way. Another way, directly we can create the object for the array list also. So this many ways we can create object and we can add the data. So all are same only. Array list, so data equal to new array list. So if you want to add the data, we have the add method, data dot add method. So anything we can add it. So what we told as per the theory, 100 to 30, 200 is 7. So you can take it. Two hundred, and finally we added the 7. So if you want to add the n number of records, we can add it. And what I told, it will allow us the duplicate also in list interface. Entire list interface means a list, link list, wherever you want, we can accept the duplicates also. Dot add method. So duplicate 100 I'm taking, duplicate 200 also I'm taking. So the elements in 0th index is a list index based, 0th index, first index, second index, third index, fourth index, and fifth index. It will also duplicates also. There is no issue. And output, how we are inserting, the same and only will get. So the first output is 100, 30 like this. Just print the direct without iterating the element. You can see the output is how we are inserted, the same we only will get. If you want to iterate over the collection, you have the different ways to iterate, either using the iterator or for each method. Okay, or if else blocks, we can take it. So the normal way, if you want to iterate over your collection, so data dot the for each method is the integer type or type of data we can take, and we have the iterator. Iterator, iterable is the root interface. In that we have the iterator also sub interface like that. Iterator is a universal cursor. We can iterate over any collection data. itr equal to where we need to iterate in the collection object dot iterator. Here we have the three methods actually. Iterator interface contains has nest and remove method. So using that we can iterate, and if you want to remove the element we can remove it. So while itr dot has nest, just print it. itr dot nest save, run on Java application. You can see the output insertion order. Even duplicates are also accepted in list objects. Insertion order. We are setting the same output only we can expect, and it is for the array list. So what I told in the theoretically, array list is index based storage. Output is insertion order only, entire list objects. Linked list is node based storage. Output is insertion order. Vector and stack also same. Vector is index based. Stack is last in first out, but output is insertion order only. So just observe it. So array list we have done. The same way I am taking for the linked list also. Only storage mechanism is different. The output is same. Linked list. Linked list is node based storage. New linked list. Save and see the output. Duplicates are permissible and acceptable, and insertion order. Duplicates are available. You can see the entire list object. Only you have to remember the points. Index based storage array list, node based storage linked list, vector is index based, stack is last in first out. The output is same for all the implemented classes. And you can see the vector also. See the output vector, duplicates are there, and output is same like the previous classes. Right. The list stack also last in first out on storage mechanism is last in first out, but output is same. How we can find the last in first out? Okay. We'll show the one example on this stack methods. New stack. See, so entire list objects duplicates are allowable, and insertion order output based upon your implemented class. The storage mechanism is different. Array list index based, linked list node format. So what is index and what is the node? I told. Vector is index based only. Stack is the last and first out. I have explained clearly how it will store in the last and first out hierarchy. Output is same insertion order only. But how to identify the last and first out element? Okay, save and execute. 200. Now coming to the last in first out hierarchy identification, and for justifying the what I have given the theory. Now you can see the few methods we have in the stack class. Last inserted value is the 200. It will be in the top position in the our stack element, the object. Okay, the you can check it. So stack object contains the last in first out hierarchy. The last 200 it will be in the top position. How to read the top position element? Data dot peak method we have. It will print the top position element only. You can see single element is the top position. So what is the 200? So for getting the confusion, I'm taking top element from stack list. See, and if you want to add the data in the top position, we have the push method. Data dot push method will add in top position. So any element you can add it. Now 500 is in the top position. Again, if you want to see the top position element, the same You can take it. So see the output 500. And if you want to remove the top position element, we have the pop method. Top element removed. Help up pop. And peak is printing the top element, push is adding the top position element, and pop is removing the element. See. So like this, we can identify the last in first out hierarchy with help of stack class methods, inbuilt methods. So this is the story about your question. What is list in collection? So the hierarchy wise, what are the implemented classes we have? The implemented classes. So for list implemented classes, we have array list and we have linked list and stack and vector. Vector stack from the 1.0 version. So this is complete information about your list. So if you explain about this question clearly in the interview and of you, it won't take this much time, but for understanding I'm giving the many points. So anyway, you have the practical example. I have given the code how we can do it, and you have the theory points, and you know the hierarchy and how it will work, and how we can iterate over the collection simple way. So this many questions will cover in the same question number 24. And if you guys are not understanding or any confusion, any question, you can write your question in comment box. We'll discuss in detailed manner. And so please make sure to subscribe our channel, because the watching is the more than 200 plus also it is coming, but subscribes are very less. And second thing, if you share to your friends, maybe if you don't want to crack your interviews for Java developer role, but who are looking for the Java position in any company, if you want to help them, please share our videos to learn the Java from scratch or to crack the interviews. The question to answer, how we can go for the best way to crack the interviews. So you can help at least to the your friend unable to provide the job from your hand, but at least if you share the questions, they can able to crack and giving knowledge and referring to our subject. Thank you to everyone, and please subscribe and share to your friends. Thank you.